Alright guys, we're back with functions, and the area of functions we're looking at is composite functions, and this session is actually our last session on functions. So we're going to kick it off with the review question that was posted. We're going to do the solution to this first, and then you can compare the answers from this video with the ones that you got. So I'm going to slide this over here and get the ball rolling with the review question. So we're going to take a look at the solution. And we're told that given f of x is equal to 8x plus 12 and m of x is equal to 2x minus 5, determine, and part 1 says f of m of x. So in answering part 1, which is asking us to determine f of m of x, if you remember the whole kangaroo discussion from last class, the first thing we're going to write is what the function f of x is. So we're writing that one first of all, and that function is 8x plus 12, and we're going to write the baby function, which is m of x, and that is 2x minus 5. And in having the discussion in last week's class, we said that the baby kangaroo here, if you kind of remember my very prominent drawing on the kangaroo with the baby inside. All right, let me see if I can replicate that drawing here. So if you compare this with this, obviously this is the mother kangaroo, the baby kangaroo is here. Here are the eyes. Okay, so the mother kangaroo, the baby kangaroo. So the mother kangaroo would be f of x, and the baby kangaroo would be m of x. So we put the mother kangaroo first and the baby kangaroo. What the baby kangaroo is going to do is jump in the pouch of the mother kangaroo, and that means where f of x is. So we're replacing x in the mother kangaroo with m of x. So therefore, f of m of x is going to be equal to 8, but instead of writing x, we're going to write whatever this is. So we're replacing this x with this function, 2x minus 5, and then we're going to put back plus 12. As simple as that. Afterwards, it's basic expansion. So 8 times 2x is 16x. 8 times negative 5 is negative 40. And we're going to put back the 12 there. So we have 16x. And of course, you have $12 at home and you owe somebody $40 and that person is coming for it. You have to give them the 12 and you're still going to owe them 28. So therefore, f of m of x will be equal to 16x minus 28. So I've answered that part of the question. Now we need to move on to part 2, which is asking us for f of m of 3. Now in an exam they could have just asked you this question straight to find f of m of 3, but in order for you to do that, I gave you two methods of doing it. If you opt to do the first method, you'd have to find this first and then find f of m of 3, or you find m of 3 first and then f of m of 3, whichever method that you prefer based on last week's session. So we're going to use the first method anyway, because we found f of m of x, which is equal to 16x minus 28, and what we're going to be doing is just substituting the x with the 3 to find part 2. So let's get into part 2 quickly. So I'm just going to put this up here so we can still look at it and proceed to answer part 2. So we're finding f of m of 3, and we need this to find f of m of 3 if you're using the first method. So since f of m of x, which is what we found in part 1, is equal to 16x minus 28, then f of m of 3 means we're simply replacing x with 3 inside here. So it's going to be equal to 16 times 3 minus 28. And 16 times 3 is 48. And 48 minus 28 is simply going to give us 20. So therefore, f of m of 3 is equal to 20. And that means we're finished with part 2 as well. So we're going to move on now to part 3. Very straightforward problems. So part 3, we're being asked to determine m of f of x. So we're asked to determine m of f of x. Now again, this would be the mother kangaroo here, because this is at the back. So you write that one first, and m of x is equal to 2x minus 5. The baby kangaroo, which is at the front, is f of x, and that is equal to 8x plus 12. And again, what is the baby kangaroo going to do? The baby kangaroo is essentially going to jump wherever you see the pouch. Very, very simple. So, therefore, m of f of x is going to be equal to 2, open bracket, 8x plus 12, and we put by the minus 5. So we expand here, 2 times 8x, that's 16x, 2 times 12, that's 24 minus 5, and that is 16x plus 19. So therefore, m of f of x is equal to 16x plus 19, if you want to make the statement at the end. Now we're moving on to part 4. And again, if I'm using method 1, I need m of f of x to determine m of f of negative 1. Very, 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 very simple. So I'm just going to keep this in the picture so we can see it, and then move on to part 4, which is asking us for m of f of negative 1. Now, since m of f of x, since m of f of x is equal to 16x plus 19, since m of f of x, which is what this is equal to 16x plus 19, then m of f of negative 1 will be 16 times negative 1. We're replacing x with negative 1 plus 19. That is negative 16 plus 19, and that is positive 3. So therefore, m of f of negative 1 is simply equal to 3. And that is what that is. All right? So we're going to move on now to the last part of the review question, which is asking us for m squared x. So part 5, m squared x. And we know that m squared x is the exact same thing as m of x. That's what this is, right? So m squared x is the same as m of x. So again, the mother kangaroo is here, so m of x is equal to 2x minus 5, and the baby kangaroo here is also m of x, and that is 2x minus 5. And again, the baby kangaroo is going to jump wherever x is, and that means, therefore, m of x is equal to 2, open bracket, 2x minus 5 minus 5. So this is going to be 4x minus 10 minus 5, which is equal to 4x minus 15. And since m of x is this, and m of x is the same as m squared x, then, therefore, m squared x is equal to 4x minus 15. And that will take care of part 5 of the question. All right? So I hope you guys got all of those correct, and that you have picked up everything discussed in the previous lesson in the last week, Saturday. And we're about to move forward now with a little bit more challenging compound questions in composite functions. So I hope you guys found this video insightful, and I'll see you guys on the next video.